Hello everyone, my name is Pankaj Chavan and I will be your instructor for the course on heat transfer. In this course, I will try to cover the basic concepts and foundations of different modes of heat transfer, that is conduction, convection and radiation. At the start itself, we should make ourselves very clear that the fundamental concepts of heat transfer can be used to solve many practical problems. And here in this video, I will show you different practical problems in which the concepts and principles of heat transfer are very useful to design and size those practical systems effectively. First, we should understand what is the meaning of heat and heat transfer is. We often experience that a hot coffee left in a room cools down and a cold drink warms up. And it occurs due to the transfer of energy from the warm medium to the cold one. So let us consider a cup of hot coffee left in a room, and here we consider this cup of hot coffee as a warmer region because it is having a higher temperature, and we consider the room as a colder region because its temperature is less as compared to coffee temperature. And hence, because of this temperature difference, there will be a transfer of energy from this warmer region to the colder region, and because of this, over a period of time the coffee will get cooled down. Similarly, when we consider a cold drink, there is exactly a opposite situation we have, in which this cold drink is having a lower temperature and hence it becomes a colder region, and the room is having a higher temperature as compared to cold drink, because of which now the room becomes warmer region, and hence there will be a transfer of energy from room to the cold drink and the cold drink will get warmed up. Here we can see the third example in which two metal blocks we have. So block A is having higher temperature as compared to block B, and when these two blocks they will come in contact, there will be a transfer of energy from block A to block B, which is nothing but the transfer of energy from higher temperature region to the lower temperature region, and after some time both these blocks they will come to the same temperature level, and we call this situation as the condition of thermal equilibrium. So from this we can conclude that there is a transfer of energy from higher temperature medium to the lower temperature medium, and hence heat is known as a form of energy which is in transit, because this is nothing but an energy which is getting transferred from one region to the another region, from one medium to the another medium, and hence heat is known as the form of energy which is in transit. And the study of such a energy transfers per unit time, it is known as heat transfer, because we are also interested in determining in what time duration this transfer of energy it will occur from one medium to the another medium, and the subject of heat transfer is all about this. Now we should understand what is the exact difference between thermodynamics and heat transfer, because in thermodynamics we have studied about energy and energy transfers, and in heat transfer also we are going to study about energy and energy transfers, but there is some key difference in between the two subjects. Through one example we will understand what is the difference between thermodynamics and heat transfer. So let us consider a thermos bottle in which hot coffee is stored, which is having initial temperature of 80 degrees Celsius, and over a period of time, let us say the coffee cools down from 80 degrees Celsius to 70 degrees Celsius. Now, when we make use of thermodynamic analysis, we can identify what is the amount of energy transferred from hot coffee to the surrounding when the coffee cools down from 80 degrees Celsius to 70 degrees Celsius. But the thermodynamic analysis can't tell us about in what time duration there will be a decrease in temperature from 80 degrees Celsius to 70 degrees Celsius. So here the role is played by heat transfer. So heat transfer is the subject which will tell you about time also. So it will tell you in what time duration the coffee will get cooled from 80 degrees Celsius to 70 degrees Celsius. So this is the first key difference between thermodynamics and heat transfer. And thermodynamics, it deals with only the energy transfer either from one system to the another system or from system to the surrounding. It will not tell you about in what way the energy is being transferred from one medium to the another. But heat transfer, it will tell you in what way the energy is getting transferred, and which is nothing but the different modes of heat transfer which are known as conduction, convection and radiation. So these are the two key differences between thermodynamics and heat transfer. That's why we are studying heat transfer separately as compared to thermodynamics. Now I will discuss about the different practical systems in which the use of these concepts are there. So the first system that we'll consider, it is the thermal power plants. So in thermal power plants, there are number of devices in which the exchange of heat takes place between working fluid and the surroundings. So examples that we can take, they are like boiler. So here we have steam boiler and condenser. So steam boiler, it is a device in which there is a conversion of water to steam, and this steam, it is fed to the turbine, and the turbine blades will rotate and they will give certain mechanical work output. So this steam, it is very useful in turbines to produce mechanical energy, and this steam production, it is done in a device which is known as boiler. So in boiler, what we are doing is, in some portion with the combustion reaction, we are producing a large amount of heat, and then this heat is supplied to water which is flowing around it. So this heat, after supplying to water, the water will gain energy, and after gaining a very high amount of energy, it will get converted into steam. So here we are interested in determining what time the water will take to get converted into steam. So this time element, again, it is related with heat transfer. With thermodynamic analysis, you can identify like what amount of energy will be required to convert some mass of water into steam, but it will not tell you in what time duration it will occur. And because of this, we can say that the concepts and principles of heat transfer are useful when you are designing systems such as boiler. Condenser is a system in which there is a conversion of steam into water. So when the steam is given to turbine, the turbine will do its work and the steam will come out. So when the steam, it will come out, it will have very low pressure and some temperature. So this steam have to condensed again. So this steam has again to be converted into water, and that water will be again fed back to boiler. So there is one system we have which is known as condenser unit, in which the steam which is coming out from turbine, it is being condensed, and this condensed water, then it is again fed back to the boiler. Here also the principles and concepts of heat transfer are very useful when we are designing such a sort of systems. So let us consider some another system which is related with automobile components. So in an automobile, we know that there is a system we are using which is known as radiator. So radiator is nothing but a kind of system which is used for engine cooling. So engine, when it works for a very larger duration of time, what happens is it continuously works, and because of combustion reaction happening and producing the mechanical work output, the temperature within that region, it increases to a very high level, and because of this, the engine walls will get heated up. So if the temperature of the engine walls continuously rises, then there might be chances that the engine will not work effectively, and in that case, we need to extract heat from the engine walls, and radiator is nothing but one unit which helps in extracting the heat. So what we have is, around the engine there are some pockets through which the water or some coolant can be circulated, and this water, when it circulates around that particular engine, so when it circulates around the engine wall, the water will get heated up, and this heated water or heated coolant, it will then get supplied to this radiator system. So this is the point at which this heated water coming from engine, it will get supplied, and it will get collected into this inlet tank, and now from this inlet tank, it will enter into this tubes. So we have here a bundle of tubes into which this heated water or coolant, it is entering. Now when it is traveling from this inlet tank to the outlet tank, behind to this system we have one fan, so which continuously rotates and it supplies air at with certain velocity. So this air, it will move and it will come in contact with the outer surfaces of these tubes. So when it is coming in contact with the outer surface, as air is having lower temperature and this heated water coming from engine, it is having higher temperature, there will be a transfer of energy from this hot water to the air, and hence this hot water will get cooled down. And again, what happens is, this water will get collected into this outlet tank, and from this outlet pipe the water will come out, and again it is recirculated through the engine walls. So this is nothing but a one kind of system in which the concepts of heat transfer are very useful. What size of these tubes to be selected, what should be the dimension of this system, all these things are decided on the basis of concepts of heat transfer. Now, in addition to this, we are also using such a systems shown here, which are known as refrigeration and air conditioning systems. So in refrigeration systems, what we are doing is we are having certain space within which there is a very low temperature region we have. And this low temperature region, it is created by extracting the heat within this region with the use of refrigerant. So again, here there is an involvement of transfer of energy or exchange of energy between working fluid and the surrounding, and hence we can say that here also the concepts of heat transfer are very useful. Now, in addition to this, in air conditioning systems also there will be a use of heat transfer concepts. And whatever the systems that we discussed till now, they are all traditional systems. These are all traditional heat transfer equipments in which the principles of heat transfer are very useful. But in addition to this, the concepts of heat transfer are also useful in manufacturing systems also. So here you can see one system which is used in metal casting process. So what we have here is a furnace. So this tilted portion is a furnace in which we are putting the raw material which need to be casted. So after putting this raw material in this furnace, what we are doing is we are heating this raw material and we are converting that raw material into liquid molten metal, and this molten metal then it will get collected into a ladle. So this portion in which we are taking this molten metal, it is known as ladle. So into ladle this molten metal will be taken, and this ladle will be taken now towards the mold into which it will be poured, and we are producing castings. So here you can identify that when it is getting poured into this into this ladle, so surrounding temperature is less as compared to liquid molten metal temperature, and because of which there is a transfer of energy from this liquid molten metal to the surrounding, as well as when this ladle it is being transported from this furnace region to the point at which it is being poured, within that duration also there will be a transfer of energy from this liquid molten metal in the ladle to the surrounding, and hence here there are involvement of the concepts of heat transfer. The second thing that I am showing here, it is nothing but a welding operation, and here itself you can understand that in welding operation we are melting the metal and then we are joining two different materials. So this is nothing but a kind of process in which there is a involvement of transfer of energy in the form of heat, and hence the concepts of heat transfer are useful in traditional equipments as well as in manufacturing systems. Now here whatever you can see is whatever you're seeing, it is nothing but some emerging trend we can see in which the concepts of heat transfer are used. So here we can see one circuit board on which different systems are installed. We have chips here, and this is nothing but a circuit board which is used in electronic equipment, and we know that nowadays we are using laptops, electronic systems which are very fast, and we want these electronic systems to be compact in nature. So our requirement is compact electronic system, but they should also have the higher processing capabilities. Now because of such a requirements, what is happening is whatever the chips we have here, so they are continuously working and working with a very high processing speed, because of which there is a generation of high amount of heat, and this high amount of heat has to be extracted effectively. So here again in this electronic equipments also there is a need of concepts of heat transfer to be implemented effectively, so that the energy transfers from these systems which are known as electronic chips have to be done effectively, and hence it will extend the life of electronic chips, and hence it will extend the life of electronic components. So these are nothing but the different practical systems in which the concepts of heat transfer are very useful, and this is this is all about the practical systems I want to tell you about. So thank you very much for listening.